Welcome everyone to OTF webinars. Tonight's is fractions from representation to operations. Oh, you've got a great one lined up for you. Our presenter tonight is Matthew Oldridge, and we were lucky here in Kitchener to have had Matthew present at the TEDx EDU conference that we had. He's got a wonderful wealth of knowledge in this area. By the way, he's also got a terrific Twitter account, which I will be sharing with you, and so many resources that I'm sure you'll walk away with wonderful ideas. So here we are with Matthew. Take it away. Just in case you didn't hear me, Matt, you can take it away now. We're all set for you.
Can you hear me now?
Yes, there we go.
I was on, then I clicked off. So
okay.
The one thing I just said was I was echoing the sentiment about TEDx Kitchener Ed. I'll go next year just to watch. It was a terrific slate, terrific event run by Andrew Boronsky, a Waterloo Region teacher. So highly recommended to anyone here. Anyway, welcome. So tonight we want to talk about fractions, representations, and operations. And this webinar is, I just wanted it to be a narrow slice of the topic. We learn the most about math by doing math ourselves. And so it'll take you a long time to come to know fractions, to really come to know them. And a lot of careful, patient work, and most importantly, thinking. So I wanted to highlight some recent, stuff in the area, because Ontario has a lot of stuff, and some few ways to think about fractions, and a few ways to think about fraction operations. So because as you progress through the grade, the operations come in, and it's so important to not just to do the operations, but to just build the conceptual base first. And it's hard. It's hard work with multiplying and dividing fractions in particular. So, but with careful and patient work, fractions can be your friends as well, as they came to be mine. And then further to the point, the links tonight are mostly from the Ontario fractions research. I'd say spearheaded mostly a whole bunch of people from Trent University and people across the province. So Kathy Bruce and Shelley Yearley in particular as two who have done a lot of the work. And so just to call attention to that, they have research papers on adding and subtracting, multiplying and dividing fractions. There's a fraction learning pathway. Paying attention to fractions monograph. That would be my volume that's too low. How am I now? Is my volume up? Just a little bit better. Okay, so we were testing it, and I was testing it a little low, but better. So I'm going to make sure I'm really, really close to the mic and that I don't go anywhere away from it. So if we're okay right now, I'll continue. Okay. Be careful about that. So I think that's everything by way of introduction. Do tweet tonight if you feel like it, or at any time. Join the conversation. It's the best professional 24/7 staff room you can have. Ways to use fractions. So sometimes I'm just looking through pictures, right? And I think of mathematizing pictures, and they just make me think of fractions. And usually with this sort of picture, we'd think about filling the box, like volume. But I was just giving us just one possible example. Fractions as volume. Probably an underrated way to think about fractions. And not so much volume as maybe liquid capacity, which is very much related. So think of filling containers. So one we might not tend to think about, the three-dimensional representation. I just said task idea, how many cubes would fill the box? But if we're going there with fractions, I mean, each cube is what fraction of the box, and so on. I stretched a little for that one, but I just wanted a picture to get us maybe thinking in different ways about fractions. So right now we need some help. Where do you use fractions? Anything like that can go in the chat box. And I think how, so is linked to where. But where in your life do you use fractions? And as well, in the classroom is fine as well. So just from experience with webinars, the broader and the more in the chat box, as far as learning from each other goes, that's very helpful. So we have cooking and building coming in, and baking and music. I think I do have a music example in this presentation. I think some of these sort of ordinary day ones we kind of tend to underrate, in that they're so common to us, we kind of forget about them. Does anyone else have any other ideas? Shopping. But feel free to give any specific examples. So building, constructing things, a third off a purchase. I think that that one reminds me that very famously, one of the fast food burger companies had a thing where a lot of people couldn't tell a third of a pound burger, but that was more than a quarter of a pound. So for some reason, well, not for some reason, people wanted the quarter with the 4 on the bottom to be bigger than a third. So it caused some confusion. Driving. So we could purposely call attention to fractions and make fractions out of things, like the road signs, how far we have gone and how far we have left to go. Those are some good examples for sure. Okay, well we wanted to get that on the table because it helps with our task creation for sure. So if we can, the more that we can, as I like to say, mathematize the world around us, the better. Okay, so calling attention to, as I was saying, the Ontario Fractions Learning Pathway Research. And so these 2 links are about to come into the box, the chat box. If you are like me, sometimes I will just listen and follow the links at the same time. It sort of depends on your online learning style, but they're there for you. So EduGains has a whole section on fractions. And as I say, they're doing like very, very specific research in some cases. To give one example, Shelley Yearley's work on unit fractions. So something as subtle as we teach kids to count, so just the whole numbers, 1, 2, 3, and so on. But when we're working with fractions, we're working in grade 1, say, if we say 1 1/2, 2 1/2, or 1 1/3, 2 1/3, 3 1/3, 4 1/3, then the eventual counting above 1, or what we strangely maybe call improper fractions, becomes more normal. And things become evener. If you think about it, all our operations are built on counting, so we learn to count. We're constantly adding 1 to get the next integer, the next natural number, and so we can build adding off of counting, and we can build multiplying off of adding and subtracting, and then we can build, so multiplying and dividing we can build as well. So if you think of counting as the basis, then unit fractions make sense. And that's just one example of something that's little and it's subtle, but we can change the language. Okay. Now I'm going to suggest to Shazadi, if you are able to, there is an audio and video wizard, if you're able to check the speakers as well and make sure everything is up. Okay, so we have one person that confirmed, just turning volume up help. Please stay with us and please do. Okay, so all is up. I've got everything all the way up as well. And I am sorry for that, and I hope it does work out. It would always be an option if for some reason it didn't, to watch the recording later. Okay, yeah, hopefully it works. So moving to, today I wanted to try something a little different. So a lot of times with these webinars, I'll try and pull everything in to the actual Blackboard. But today I thought it was important to highlight all the Matthews tools. And so that's what we're going to do right now. So it's called application sharing. So I'm going to share and go to Matthews. Okay, so I see on my second screen that you see what I see. So far so good. And you'll notice that there's games, learning tools, and activities. Many of you will know this already, but I keep calling attention to it, and that is because for 3 years I was a mathematics resource teacher, and I would always sort of avoid or duck the question about apps or digital things, in part because there's so many, in part because some of them are just a little limited. They only do one thing. But at the same time, I was attending meetings with Ontario math coordinators. And so the developers of Matthews who were working with the province would come to the meetings, and they would always share their progress. So a bunch of these tools I've seen in different versions, and they've steadily improved. And there's a ton there. So we're not going to do games right now, but there's a bunch for operations, integers. There's some for fractions, definitely. Right now we're going to highlight some of the learning tools. And just have a little scroll through, and we're going to notice how many of them can be used to support fractions. So the colors tiles tool is exactly what you think. Okay, it's just colored tiles in digital form. That's quite a good app. Integers, whole numbers, we have decimal number rods, growing patterns, but fraction strips here. So a very powerful tool. Very powerful tool for comparing fractions and adding and subtracting fractions, even possibly multiplying and dividing. Continuing on, Geometry Sketchpad is now here, and the gizmos. The Money app, which could support our work with fractions, that's right there. Notepad is what we're just about to use. There's a number chart, a number line. Partitioning sets. So there's a specific fraction one about partitioning, which is partitioning is dividing things into subsets. Pattern blocks can definitely be used for fractions. This one, I mentioned the area or volume model already, but there is a pouring containers one. So having to do with how full a container is. So we can already see that we have a three-dimensional model, and if we're looking at the tiles and particularly the fraction strips, two-dimensional or area model. Probably we could do something with the number lines if we wanted to. Number lines being possibly a one-dimensional model for fractions. We also have the relational rods, which are sometimes called Cuisenaire rods when they're that brand. So they are right here as well. Very useful tool. My most popular tweet last week was about Cuisenaire rods. So there's a lot of them dusty sitting on shelves. They look exactly like as pictured in relational rods, and they're a very powerful tool for fractions. And then lastly, there's the set tool. So a big point made by, I suppose particularly by Marion Small in her books and others, kids don't tend to think of sets of different objects as having fractions. For example, in the picture, 3 stars. So just in the 10th frame here, 3 out of 7 are stars. but 2 out of 7, sorry, are purple stars. 2 out of 7 are green stars. But there's a 3 to 2 to 2 ratio of all of them, and that's the sort of thinking that needs to come in as our students go through the grades. So the more part-to-part thinking, and I have a slide about that coming up. So what I'd like right now, I'm going to show you the notepad, and then I'm going to go back to Blackboard. But this is where there's 2 tasks coming up that you're going to be able to try. So when I open it up, you'll see this, and you'll choose a background. I'll just pick maybe plain this time. Okay, so the key is this picture or portrait. And so I have the 2 tasks ready to go. So I can just drop them in there. And so one of them that's coming up is called Quarter the Cross. I'll just drop that in there. I can rearrange it. I can spin it around, which is interesting. So I can put a picture in, okay? And from there, I'm going to be able to do the writing that I need to do. And I think whether you have Chromebooks, iPads, the Matthews Notepad is a powerful capture tool for capturing kids' thinking. You know, there's a lot of them out there that do that, but, you know, your Educreations and your Show Me or whatever, but they all have different sort of paywalls where you hit the paywall, or different sort of options for free, freemium, or even in some cases they want you to buy a whole class. But in this case, though, if a student was doing their work on this task, then you could easily upload it to their Google Drive as well. You had your iPads handy. So that's where we're going to go. Okay, so what was key here was I had this called cross, and it says PNG image, so it's a screen capture. Okay, so for myself, this laptop there is under. Yeah, that doesn't work actually. Only the browser. See, that doesn't work. And it left the black box on the screen. But on this Acer laptop, under accessories, I have a snipping tool. So hopefully you know how to do that. So when I refer to screen capture, I'm referring to the snipping tool. So I literally snipped this slide, and literally snipped this slide from the presentation. Okay, so I'm stopping sharing Google Chrome now and coming back to the PowerPoint in Blackboard. So yeah, so I just press this and we're back. So what I wanted to show you this time, weighted question comparison tool can be used too. If for some reason, in the little talk I gave, if you were inspired by one of them and you wanted to try something different and screen capture it, having to do with fractions, you've got to do that. It's the adult learning model and the curious learning model. You've got to go where your learning takes you. But otherwise, we're going to take a screen capture of the next 2 apps and upload them into Matthew's Notepad, which is just what I just showed, to do the math. I do think we have potential for digital math these days, especially with, you know, fairly ubiquitous tablets and Chromebooks. So in a lot of these webinars, I haven't emphasized that as much, because it's true. Here, let's go to the task. You could easily just photocopy a few of these for kids, easily. And maybe you still want to have a few. But with the digital option, it's just different. It's just different options. I think maybe we owe it to ourselves to give it a try for sure. Some of our kids will relate to it. Some of them will want to do the work on iPad. Okay, this is the spot where I would like it if you would screen capture this task, or just a cross, and save it. So my usual saving spot would be just drop it on the desktop, because it's easy to delete later. Now go back to the Matthews apps, and actually we will leave a good, I want to even say like 8 minutes on the clock. I think we can put a timer on. And then what I would like, if you can, I'm going to put my email in the box. If you get something good, save the file, which is an option in the Matthews notepad, or screen capture and save it. Regardless, send it to the email address I'm just putting into the box, and I will drop it into a blank slide. And so the reason for that would be, we know that we learn best and students learn best. Okay, so we learn the most about student thinking when we see lots of it. So if it was a class, you'd certainly be looking at the set of solutions and seeing how they're alike and how they're different. By the way, on this particular task, which is used all across the world, there is some websites that have just like really astonishingly beautiful work. And what's funny is I have done this live in person with a bunch of adults, and some of them will do the most basic thing and just be done. And so I always try and push them to sort of, well, what's a more imaginative representation of 1/4? But then the more basic or simpler ones do matter. But it's just sort of how far can we take our thinking. And I think that's where the beautiful diversity of the student work and the beautiful diversity of their thought is so important. And so we learn the most by looking at lots of different thinking. So if you can send me those emails, I can just drop it in a blank slide. And the good news is they'll be in the recording as well. So if anyone were to watch this webinar in the future, they'd see, well, there's some work captured forever. And if for some reason you don't choose to send it, we'll still have this 8 minutes to experience doing the math and Matthews. Okay, so I'm just going to pause my talk. So definitely feel free to continue if you're continuing. I'll just talk about the one that I've got. Just be mindful. So if that was totally new to you, and it was your first time, yeah, maybe it was slightly frustrating, or maybe you found it natural. I just think with a lot of the technological tools, it's just deciding when they're good and when they're not good. And that's what's important about it. So in the one that we've got so far, we have each of the squares divided into quarters, and then we have 5 of them smudged in. So we have 5 pieces times 1/4, 5 quarters. Or we could count like I was talking about, 1 1/4, 2 1/4, 3 1/4, 4 1/4, and 5 1/4. As it happens, so the more you do a task and the more work you see on a task, this solution will come up for sure. Just a quick check if we've got any more yet. Not quite yet. That's okay. Feel free to send them, and I do want to have another try with the Matthews on one more task coming up. But we'll talk a little bit more about some fraction things first. First, just to be clear that there's a circle thing in the top right in the Matthews notepad, and I think on a full computer, haha, so Sharon's done. Okay, good. So I'm quickly going to. Okay, it looks like the one you sent is the blank one. Maybe double check that. Oh, yeah, I was going to double check it's the blank one. And I look forward to seeing what he did, though. Okay, and so you could decide what it matters to talk about fraction representation with this task. I think the beautiful thing is when there are 5 squares, obviously in this case, and we're asking for quarters, we're disrupting students' thinking about wholes and pieces. And I think you'll see a lot of tasks these days about chocolate bars, for example. Some of my colleagues just did one yesterday where it was 3 chocolate bars divided by a certain number of people, 2 divided up in a certain number of people, and 1 divided up a certain number of people. But it was interesting because they were divided into squares themselves. And you'll see a bunch of tasks of that sort of genre where it disrupts your thinking because it's not neat and clean. Whereas we could, if we think of just dividing, we divide 5 divided by 1/4, and we get 1.25. I'm just quickly dropping Trish's in. Yeah, Sharon, if you don't mind checking, I'd love to see it. Quickly dropping the page in. Okay, here's another one where it almost makes some kind of pattern. So again, we see divided into, oh, that's good. Don't get frustrated. Some of these technological things just take a little while. So we see neat pieces divided into fourths. We may notice if we were going there with fraction division, say, that we now have 20 pieces. So 5 divided up into quarters, we have 20 pieces. And that's a bit of an argument right there that 5 divided by 1/4 gives you 20 pieces. You know, and it just depends what grade and what our learning goal is. What I said doesn't make any sense, sorry. Oh, sorry, yes it does. 5 pieces times 4 is 20. Yeah, and so it depends on the grade and the learning goal. So if we're just at the representational stage, we may be just looking at the different ways to represent fractions or count with them. And if we're at the operational stage, we may be thinking something differently. Okay, and what matters at the representational stage is giving students lots of different chances and opportunities and ways to think about fractions. So I can't emphasize that enough. I think this one I forgot to put the link in, so I'm going to drop it right in. It's fractiontalks.com. And what's interesting, I called this a reasoning routine because literally it's just crowdsourced provocations about fractions. And so there's different sections on there, and one of them is flags. And so a lot of great tasks have come out of flags, like flags of the world. And I know people that have a whole set, basically, and they can pull them out. But, you know, whether you have them or you're looking them up on the internet or not, they're all pretty good for fractions. And so it was, yeah, there's some nice tasks out there based on fraction talk. And so, so one of the sections is flags, as I mentioned, and other sections, there's quite a number. I suggest you go to fractiontalks.com. So you could, for a period of time, you could pull out one sort of task per day and have kids reason out loud or on paper, if you wanted to do it that way. So strengthening their skills with talking about fractions. But I wanted to sort of emphasize and repeat that the more ways we give them to think about fractions, the better. This one is on there. I'm going to come back to that. That's going to be our second try in Matthews, but I'm just going to talk about a couple of things first. I once visited Margaret Allen's grade 1 classroom about 2 years ago, and she had kids make their own fraction strip kits in grade 1, which the curriculum asked them to deal with fourths. halves and fourths or quarters, and that's directly the language from the curriculum. And so she was just playing a game where you roll a dice and you're trying to fill the full piece without going over. And so that's what this picture shows. So it was the gameplay and the consolidation after. But what I wanted to say about it was there can be this kind of weirdness. So kids may think that something weird or strange is happening. Why? They learn to count and sort of they're born, the rote counting sequence is in the air, seemingly in the air. I have a 5- and 7-year-old and they still, let's just say their musical vocabulary is very limited. So you could be like the middle of July and you'd get like some Jingle Bells, Batman Smells, or you'd get spontaneous alphabet songs. Like to this day, I have to say, like no alphabet song, because they know the alphabet and there's a limit to how much you can hear it, right? Or like Mary Had a Little Lamb, like over and over and over. But they'll also do like spontaneous counting as well. And it's just what kids do. And so they think, okay, well, that's the only way to count. And those are the only types of numbers. And I think sort of as educators in primary, it's our job to make sure kids don't think that. Okay, and here's the thing. With my kids, if I'm sharing like a cookie, say, unfairly, so fractions is fair sharing, dividing is fair sharing, they're going to tell me about it. And they're going to get mad. But if I were to introduce the formal notation too soon, yeah, maybe they might get confused. But I think it's just naturalizing the idea that there are these types of numbers and what do they mean, and that they're not weird. Okay, so have you ever had, and maybe in the junior intermediate grades, have you ever had the plastic fraction circle set? It comes in a plastic circle case. It's a total nightmare to get back in. The kids spend like 10 minutes putting them away, and then the end of the day comes and you find like a little green 1/12 piece on the floor. Yeah, that's not cool. And so the good news for you and for me, the pizza is overbaked, so we kind of tend to overuse circle models. Why is that bad? Rounded edges are hard to account for. It's easy to divide it in half as is pictured, but the rounded edges are hard to account for. And that makes, frankly, rectangles much better. They're easy to divide up without making a mess. I actually still remember being taught how to divide a circle into thirds as a young child. And it was, teachers had to resort to, this was primary teacher skills at the time. They had to teach you to draw the Y on your circle. And I could never make a nice Y, so I never had nice 1/3, 2/3, 3/3 anyway. So, whereas if I were to have like my fraction strip divided into thirds, honestly, print the fraction strips in color, tape them to laminate them, tape them to every kid's desk. Like, the pizza is overused. It doesn't mean it should never be used, because frankly, in the real world, circular pizzas are pretty much always divided into eighths. So there's a context right there. But I think it's just not overusing it. And as some people sometimes point out, well, the party pizzas are square or rectangular. As Anik points out, Anik, sorry if I mispronounced your name, too difficult to represent fractions by students with circles. Yeah, it very much can be. And drawing a perfect circle by hand is a nightmare, or even close. So zooming out, we can make our instruction about big ideas. Because numbers are interesting, and there's a lot of big ideas about them. And we should open this field of thinking really wide, right? And so there are an infinite number of possible ways of naming every number, which applies to fractions or any other type of number. And so that's a really important idea. And it goes to equivalence. And usually we just teach, well, okay, let's find a bunch of common denominators. But maybe framing it through the bigger idea would help. So all of a sudden 1/2, 2/4, 3/6, 4/8 makes sense rather than just, a procedure. Now we would have to come up with ways and using thinking tools, and picking the right problems to make it make sense. But that's a really massive idea. Okay, and then so we can ask questions like how many different ways can you show 1/2 or 1/4? Have all your manipulatives, all your thinking tools out. Think of different ways to name things. That's important. And a point that I'm going to make I've been making throughout, I'm going to explicitly make again, fractions can represent parts of wholes, parts of sets, and parts of measure. So 1D linear, 2D area, 3D volume, for example, but also dividing, like the bar between numerator and denominator signals dividing. That's a valid operation. Or it can signal ratios. And the reference here is a must-read. I keep it by my bedside table, paying attention to fractions monograph. I don't really keep it on my bedside table, but it is that good. It's just that good. And contrary to popular belief, I don't read math monographs when I'm falling asleep. Just every other minute of the day. And then so, yeah, this was when I had grade 6. I just like this picture because we were just talking about, I believe the question was, how many ways can you make one whole? And sometimes you open up the question just like that, and you get really, really interesting things. So you can see that they have a lot of things on the paper, including some addition sentences. So I would say that's probably prior knowledge, but they're looking at different ways to represent one whole. So, and then another massive idea appears right there because the size of the whole matters. And we're talking about 1/4 of one whole will be a different piece of another whole, you know, and it could be quite a different size piece if we're changing the size of the whole. One tool you can really, really think about is those Cuisenaire relational rods, because different relationships exist. There's a 10 unit one, and you can treat that as one whole, but you can treat any other one as one whole, barring probably the 1 unit. The different relationships will exist, and that makes it a powerful tool for seeing that. So considering the whole, and that's just frankly kids, adults. I mean, we get messed up. Like if we're going back to I believe it was Wendy's hamburger, 1/3, you know, and the public thought it was smaller than 1/4. I mean, first of all, there's some numeracy, some math literacy that's missing. But second of all, it's in relation to the whole that is a pound in that case. Just kind of the standard unit for hamburgers is a pound. So in relation to that. And then so hopefully consumers could reason out that 1/3 is just a little bit closer. It's just a couple more ounces of beef. This one was, yeah, so students were thinking of, same question it was, but you know, they thought in terms of percentages. They thought actually in terms of, and this is, I want to say grade 7, but they thought of so far as saying n over n, which is pretty good for grade 7. A lot of kids wouldn't say that. So we get 3 over 3, 18 over 18, 152 over 152. So just by asking this question, you could try it in any different grade. I think you get good stuff. But here we had the whole note in music. So all of a sudden this is transferring over from music class. Whole note, half note, quarter note, eighth note, and then 12/16 if you're into Metallica and things like that. Food, and we always get fractions of food. So the whole matters. Oh, this was the world being land and sea on its surface. I simpled that one out because they just wanted to look up that information and do a little comparison. So one whole being this number of square kilometers. I thought that was interesting. And we could indeed express these weirdish numbers as a fraction. Maybe we'd round them. Okay, and a point that maybe we don't often make as we should. Okay, as much as we should is that there's an infinite density of rational numbers. And so the rational number being of the form m over n, so just a fraction. So an irrational number being one that can't be expressed neatly as a fraction, an integer being positive, negative in numbers, the whole set with 0. Rational numbers being different from that, but still this infinite density being there. And so we could take a certain segment of an open number line, and some people like to hang them from clotheslines, for example, and you can pin them up. There's a lot of great tasks for that. Or to stand kids in order, you could lay it out and tape on the floor. But I want them to get weird ones, like 7/11 is kind of weird. 19/21 is kind of weird. But I want them to place those on the number line. I want them to stack, equivalent ones above each other. I want them to, just some interesting things to ask, but I want them to know that there is space between 99 hundredths and one whole. There's always space, no matter how much fraction you put. By the way, real numbers, which it's not just rational numbers, it's all the decimals. That's a different sort of level of infinity. It's not double infinity, because double infinity is still infinity, but it's this whole other sort of level. If you think of the Tower of Infinity having different floors or levels, integers and fractions are on the same level. That's unbelievable, but that's your true fact for the day. There's the same number. You can prove it. But so real numbers, any decimal, like 0.123681, that's a whole other level. I think you can imagine there'd be a lot more of those. So infinite density of those. But then you could say things like, well, what's closer to one whole, 97 99ths, or 101 and 103rds? Yeah, we could pull out our calculator later, and I think we should reason through things like that first. Sometimes there's nothing wrong with calculators. I think the only thing we do is we just pull them out too quickly. And I see kids pull them out because they're not confident, and I don't know, certain times tables, and they just pull them out quickly before stopping to even think. And I think we should think first, so we can always calculate later. But just some samples about that, and I think simplifying it down for primary junior classes, what's bigger, 5/8 or 6/10? That might be in the sweet spot for grade 4 and 5. And like grade 6, maybe 12/15 and I put myself in the spot. 12/15 and well, that's maybe 17/20, something like that. 12/15 and 17/20. Yeah, that's okay. And then have them reason out however they can. It's the reasoning that matters about the fraction. About fractions. So representing them, and then we're sort of moving towards more fluency with the notation and being able to use the numbers themselves as numbers and eventually to perform operations on them. So you could, and this was actually from a professional session. Did you know, actually, it's true that sometimes maybe we get tired at PD, or sometimes we just think it's going to be a certain way of professional learning. But I sometimes want the adults in the room are like, oh, you could take that one step further. Yeah, anyway, in this case, we had 99 hundredths, we had 1 and 100ths. That's okay. But I remember on this day, there was a bunch that just wanted to put up 1/2 and then sit down again. Perhaps we were just tired that day. But yeah, you can have some giant open number line. And then so the concept there is one of space. When we think of spatial reasoning, there's some weird connection between space and number. When I say weird is so we can connect kids' spatial sense to later ability with number and space itself to number, but we're not quite sure how. But it's an important point that we should start with open number lines even in grade 1, so as young as we can. I think that matters a lot. But that's the thing with an open number line. So the endpoints are what you make them, and then carving up the space. And then if you have any Marion Small open question books at all, there's always tasks that have to do with, you know, placing one, depending on the grade, placing 1/4, or, you know, you can get above 1 whole, placing 1 1/3, and then sort of seeing how kids' sense of space is playing out. Okay, I'm going to stop there. I'm mindful of getting to operations, but I want to attempt the same thing with Matthews. This one came from a Ministry of Education session. And this one is going to be our link through to adding as well. So we'll say if our grade 7 learning goal would be potentially we might get them to show that 1 through 10 adds to 1 whole. There's a few blanks as well, but we can leave that to them to figure out. So pull this one into Matthew's notepad. If we can actually just put 5 minutes on the clock, that should be enough. Just take a few minutes to experience this one, what you're thinking. I might suggest putting the grid paper background behind it. So we'll take 5 minutes to explore this one. I'm just going to pause the microphone again. Now, it is very likely that that one is more than a job for 5 minutes. I would encourage you to try that with whatever grades you have. It is either that copy, if you saved the copy, or I don't think I said that it wasn't. I said it was in a ministry session. It was also under miscellaneous section of fractiontalks.com. So you could do something with that. Each kid wouldn't need a unique copy if you just wanted to put it up on the screen. I would enjoy seeing Matthew's work, though. Yeah, the triangles are tricky. But again, it's their reasoning that matters and supporting that reasoning. If you do teach grade 7, you'll know that there's a few tips tasks that are about flags. And so you can use them to support adding and subtracting, which we're about to get to. And again, if you're persisting and you want to email them, feel free. On that note, I wanted to say that Sharon's, the notepad file, I just need a minute and to open it in Notepad and then save it and copy it. So when I get a minute, I'll get yours here. Then here was another one that came in. So it actually looks similar to one of the other ones. It was another quarter across. Okay, jumping ahead. Actually, a couple of final words on this one. Yeah, I think number 8 would give kids trouble. I do think the grid in Matthews would help. I see quarters initially. And then how far do we divide it down to? Do we make 8 16ths? Do we need to go any further? 32s. Okay, jumping back ahead. So do remember that tonight is just a survey. I would encourage you to explore all the EduGains Matthews stuff, the EduGains fraction stuff, the Ontario fraction stuff. There's 2 papers about to come on adding, subtracting, multiplying, and dividing. If you teach grade 7 and 8, 6, 7, and 8, those are absolutely pivotal. And definitely the monograph. So treat tonight like one person's sort of viewpoint, one person's sort of slice of this topic. and set some of that stuff aside for later. In reality, this could be many sessions, many days, or a lifetime of learning about fractions. They're amazing and they're interesting. On that note, I'll just put one more thing to explore in the chat box, and that's renewed math strategy webinars. Those are easy to find, so there's been a number on fractions. So if you get to the right place and you Googled it, you'll find all the recordings that people at the ministry have done. That's yet another spot. Okay, this slide, I guess I'm just saying this took it from the fractions learning pathway. They suggest subtly opening it up. So taking the grid away instead of that traditional sort of look where you have the grid, which is just counting. So make kids put the grid on. So subtle opening up of their thinking. And what does fraction across the grades mean? This is from the Paying Attention to Fractions monograph, so important. So we always see fraction as an operator. We start to see it as a quotient, so having to do with the operation of dividing. Part to whole, so continuous measures relative to the whole. And we know we do that with kids with cookies and pizzas from grade 1. And that's why you see this big chunk here. You see that grade 1 and 2 and 3. But notice that shrinks. And we have part to whole, so those discrete or set models. But it's leading through to in grade 4, as they're sort of showing it here, part-to-part relationships tend to come in more. And they matter more as we progress through the grades. And maybe we're thinking more algebraically, or we're thinking more in terms of ratio, proportional reasoning. So notice this. So notice, like, just cookie sharing is just not going to be good enough. Just not going to be good enough for kids. So fraction as operator. So if we think of 1/2 of 4, then we think of multiplying. If we think of scaling, or if we think of something stretching or shrinking, like an elastic band, that might be more useful and leads into operational sense. And so how is that reflected in the curriculum? I think that, come on, Darren, there it is. Grade 4, it's this read, represent, and compare, and then put them in order. Okay, that really matters, and that's really what they have to do. Grade 5, just a little bit more with the whole numbers, but then proper, and then so now poor improper fractions, we mean fractions above 1 whole, they tend to come in there. And so, and mixed numbers. So grade 6 is the same pretty much, but we somehow need to create a bridge where we're looking at equivalence. We need to create some kind of bridge to addition and subtraction of fractions. And then, so grade 8, this would be in the specific expectations, but multiplying and dividing the fractions do come in. Trust me on that one. So, but solving problems with them, more so. Okay, and so here, components of fraction number sense. So we have fair sharing here, unit fractions, which I've talked about, partitioning or iteration, all in the service of representing. We're going to eventually start talking about equivalence, comparing, and ordering. Now we come through this entire landscape, we can talk about adding and subtracting. So it's a whole lot more than just a procedure of finding a common denominator. And you can read that paper. Okay, so we are here. This is the classic error, by the way. If you haven't taught fractions much, just trust me. And so I taught a lot of grade 6. Every year this happens. You're going to start adding fractions. Somebody's going to do this. And I'm pretty sure you can see what they did here. But I was hoping if you have any energy left, just write some things in the chat box. I say pedagogical moves to make it sound all fancy, but let's say you had one individual that you wanted to give feedback to in person. How would you do it? So one suggestion coming in is fraction strips. Show me, represent it. Sure, and actually the show me, represent it, if you're used to using the fraction strips or even just drawing empty rectangles, you can just quickly divide them up. What's another option? Could be, we have the blocks. I think pattern blocks would be a good option too. Drawing it out. Use estimation. Does that actually make sense? Yeah. So we have 3/4 right here. It's already pretty close to 1. Actually, on that note, we had examples of making holes. So everyone should have as an anchor 1/2 plus 1/2 is 1 hole. If 3/4 is above that, yeah. So we have drawing it out, using blocks, making some real world connections. That's all going to help. So this is so classic, and it's not recognizing, I mean, we could say it's a problem of just notation. So not saying as we have number of parts on top of the total number of parts, but it's building that conceptual base as well. So something's gone wrong there. And our typical intervention would be just, well, okay, let's find that common denominator. But that can come later, just a little bit later. We want to make some sense of it first and foremost. Okay, so that's the classic error. So we really don't want to just deploy finding common denominator to add as an algorithm first thing. And if you read the, so the paper, it's the multiplying and dividing paper. You can find the adding and subtracting paper on the previous link. It's there. And there's some suggestions about what to do. I know a lot about fractions. I love those 2 papers. The authors are still collecting this work. There's a book that's coming out in a book form as well. Okay, so that's the classic error. That's the main thing I wanted to say. Let's do some sense making first, and then we can find common denominators. So it's making sense of parts and whole, making sure kids get that notation first. Aha, but multiplying and dividing is where understanding really breaks. So 2 numbers are supposed to get bigger after multiplication. So it's, do the operation. You're supposed to have something bigger. Put yourself in your own shoes when you were younger. We might not remember. But the students in front of us, we certainly do have a second chance with them. We can't save our own selves, depending how we learned it, but we can make a difference here. And so numbers are supposed to get bigger, but they don't. So why is that? So 1/3 times 1/4 is 1/12. Why is that? And coming up with some reasons why it's so. Also, fraction division. Ours is to reason why before we invert and multiply. Typically that's given out as a trick. Yours is not to reason why, just invert and multiply. But we can actually give some sense behind that before we deploy it. And what's more, we can look at dividing, making sense of the operation. So the example to illustrate this is, okay, starting by 2/3 times 1/4 is 2/12 without resorting to procedural trickery. It's not even trickery in this case. So multiply the numerator, multiply the denominator. Sure, why is that? I think in the interest of time, we'll definitely skip mathies here. so we don't need to do this. But what just in the chat box, how you would, let's just say it's grade 8 and you're about to teach this section, and you have this example, okay, the 2/3 times 1/4. Can we just say, put some ideas in the chat box of what pedagogical moves you'd make or how you would explain it? I'm definitely recognizing that this is one area of like big time think time. So I had to teach myself all about it. And one thing I tried, it may not be for you, it may not be to your taste, but it was cool when I saw it. If you take any sheet of paper and you divide, if you fold down into thirds, and you can mark a 2/3 section. And actually, Laura D is just describing what I'm describing with folding paper. And then you divide the other way, like as in vertical columns, but sections, into fourths. You will see that the shared area is 2/12. And so as Laura puts it, see where they overlap. Actually, oh, yes. Okay. So we all have the same idea about overlapping rectangles. Highly conceptual and good. Okay, so we can see where the shared area is. We could say 2/3 of 1/4. That works. The word of as signifying multiplying works. I think that gets us like closer to the concept. It definitely does. Okay, and there's other ideas. And I have one that you may not have thought of. So if 2/3, yeah, see where the two colors are shared. So if 2/3 is the multiplier, so acting on 1/4, what's 2/3 of 1/4? Or 2/3 acting on 1/4, so we're going to imagine a 1/4 piece. We're going to hold that in our mind, and we're going to imagine 2/3 of that. Well, that's kind of hard to do, but that will be 2/12 of what the original whole was. But if you were to think of some 1/4 length elastic band, and if you were to think of scaling, it's scaled down by 2/3. That elastic band has shrunk, so multiplication has made it smaller. So whereas if you were to think of that same elastic band, if it was like a 2 times multiplier on 1/4, you'd have 2 1/4s. So the elastic band would have stretched. And certainly if it was you were at 4 units on the elastic band and you multiplied by 2, well, that's just doubling it. That makes sense. So stretching and shrinking elastic bands is something that may work here. Okay, reset. Thinking back to last year, I feel like we also used the number line. Yeah, you could do that. So 1/4. So I think 2/3 multiplier on 1/4. Yeah, and you could mark off the partitions on the number line that you needed. I would relate that to partitioning. And as we reach the end, yeah, we don't need to keep going to mathies. You could certainly do it with students or just as easily on paper. But 3/4 divided by 1/2. Explain why. Now, procedural trickery in this case would strongly be just invert and multiply. So can anyone explain in words why 3/4 divided by 1/2 is 1.5? Definitely think on that one. So thinking about dividing fractions is the hardest thing to do. Just like thinking about dividing with whole numbers, yeah, that's kind of tricky as well. Yeah, some fatigue sets in after working all day, there is no doubt. But let's say each 3/4 piece divided in half. Sometimes it's useful if I have 1/2 pieces, 1.5 of them will fit in 3/4. I definitely think the dividing case is it takes a lot of thinking. I suggest reading the paper. We didn't go into it tonight, but you can certainly show kids why convert and multiply works. That's no problem. Okay, so in this case we're dividing in half, so there's double the pieces. So hence just multiplying by 2. We get 6/4, we get 1.5. Yeah. So I'm just about the point where I understand the tired brain, and so perhaps you're feeling like it's time to go off and watch an episode of whatever's on Netflix right now, or perhaps some local sports team, if there's a local sports team playing on TV, or just to go to bed. I understand that. So I think as we finish up, if there did happen to be any questions, please do put them in the chat box. And to leave you with, I always like to let kids have the last word. But I always just say, well, actually this year it was trendy, so that year it was trendy, so I said #math is. But really it's just a sentence stem, math is, and finish it. And kids have some insightful things to say. Math is the most powerful force in the universe. Use it wisely. And who am I to disagree? Thanks very much for coming. I know my colleague Jonathan So, I think, has one more on fractions. Sorry, my colleague Kyle Pierce, I believe, has one more. And please do stay with us in March, April, and May. I'm doing one on May 3rd called Nix the Tricks, which I was just looking at rules that expire in grade 4 to 8. And so the multiplying we looked at tonight being a good example. Yeah, so we have some from Kyle stuff, I'd say. That'd be one to go to as well. But just learning as much as you can about fractions. Do read those papers and do explore the Ontario stuff. I think I would like to say thank you very much, and do ask to stay and ask a question if you like, and otherwise have a lovely evening.
All right. Thank you so much, Matthew. Wow. I love that last quote. That's terrific. I'm just going to stop the recording and then talk to everybody.